everyone and welcome back to another YouTube video. So today I'll be solving the LeetCode question for sum. Okay, so one thing I would really recommend before going on with the solution to this is I would highly recommend that you first solve the previous questions that are 2 sum and 3 sum. I have made videos for both of them as well if you want to check them out. But I would really recommend first doing those 2 questions because when you do those, you will be able to come up with a pattern to solve this question as well. But yeah, so that being said, let's start on with this question. So like the previous questions, the goal is to find quadruplets, so 4 unique numbers, such that when you add all of them, they equal to the target that is provided. So in this case, for example, we have these numbers, and we're supposed to find quadruplets such that when you add them, you get a target of 0. Okay, that's the goal. Pretty simple question, but now let's actually see how we're going to solve this. Okay, so we're going to start off, before actually showing you the example, I want to first just go through the previous questions. So let's say you have 2 sum. Now the goal here is you have to find 2 numbers that add up to a target. Now how do we solve this? So the way we solve this is we first assumed that we're going to take a number, and then based on that, we look for a number x. And this number x is nothing else but the target minus the assumed number. So essentially, we assume that when we come across a number, we assume we have that. And then when we come across the number x, which is the target minus that number, that means that we've found a pair, right? So essentially, for the 2 sum problem, all we did is by assuming one number, we're only looking for one extra value, right? So now let's look at 3 sum. In this case, what did we do? So the way we solved 3 sum is we assumed one number, okay? And then what we did is so the remaining nums that we had, so let's just call this the remaining numbers, this was treated as the 2 sum problem. Essentially, from this we assumed another number, let's say x, and then we just found the last missing value. Okay, so essentially at this point we had a number, so we had this number dot, plus 2 other values, x and y, let's call it, which equals to target. Then we simplified it even more by assuming a value for x, and then we were only looking for the value y. So essentially, we just kept breaking it down so that we're not looking for 3 numbers. Instead, at a specific time, we are just looking for one extra number. So now let's try to follow this pattern and do the same thing for 4 sum. Okay? So essentially, what we're going to do is we have to look for quadruplets. And I will just assume them to be x, y, z, and let's say a. Sorry. Cool. And a. And this is equal to target. Okay? So first thing that we would do is we would assume a value x. Okay? So I'll just do this alongside. So let's say we assume the value 1. So we know the value 1 is going to be there. Now what we do is we look at the remaining numbers. What are the remaining numbers? Well, these are the remaining numbers. Okay? So 0, -1, 0, -2, and 2. Now what happens is the target changes. So now we have a value for y, and we're only searching for y, z, and a, right? So now what we do is instead of searching for x plus y plus z plus a equals to target, now what we search for is y plus z plus a is equal to target minus x, okay? And now we basically update the target to be target minus x. This is what we're searching for, okay? Now this is the same, and we're searching for 3 numbers. This is the same as 3 sum, right? So now we assume the value of y, okay? And we do the same thing. And then we look at the remaining numbers. So let's say we assume a value of y to be 0, right? So in this case, the remaining values are -1, 0, -2, and 2 again. That's it, okay? So now we have the values of x and y, and now we update our target again. So the target that we're looking for is target minus x minus y. We're only looking for the values of z and a, or z and a, right? So now we do the same thing. We assume a value for z, and we look for the value of a. So a is essentially all we're looking for. Now what we're going to do is we're going to kind of just go back each step. Now let's say we found a value for a over here. That also means we have found a value for this, because so now let's say we have a value for a, okay, so let's just break it down. So for target minus x minus y, let's say we found a valid a and z, okay? So now we want to find a value for target minus x. Well, that is nothing else but the same a and z plus the value y. So that will give us target minus x. That's it. And if you don't believe me on that, it's a plus z is equal to target minus x minus y. And just by simple algebra, if you add y on both sides, this is going to cancel out, right? So that's it. We're just going back each step. Now we go back another step. So now instead of target minus x, if you want to get the entire target, all we have to do is add x on both sides. This is a plus z plus y plus x. That's it. That is going to be our solution for foursome. So hopefully that makes sense. And if you could, I would highly recommend trying this out once on a array, and you should get a solution. So this is all we're going to implement, and I'm not going to do this by hand because I feel like looking at the code does make it a lot more clearer. But now there's going to be a small problem. Now this question has clearly told us that we want unique values. Now there's a small, so we could do, so a basic naive solution for this is that we could get the results, we could sort all of the individual results, and then we could remove all of the ones that are repeating. Obviously we could do that, but let's try to look for a solution without doing that itself. And what we could do is we could just sort this, okay? Show you what I'm trying to prove. So let me just sort the values. So that's -2, -1, 0, 0, 1, and 2. Cool. Okay, yeah, cool. Okay, so now what we're going to do is, let's say we assume the first value to be 0. Let's do 0, okay, because there is a repetition for 0. So let's say this is x. Now, what is the goal here? Actually, just to make it simpler, I will add a value 3, and I will add a target. I'll make the target, let's say 5, okay, in this case. So essentially what I'm trying to prove is that, let's say I chose the first number to be 0. X is 0. Now I'm finding the other 3 numbers. So for this case, obviously, a possible solution would just be 0, 0, 2, 3. So now what happens is, let's say now I go to another 0 over here. In this case, well, actually, I don't even get to the target 5. But just for the sake of it, let's say I add another 0 here. So in this case, I would get the same solution, right? So these are the numbers I'm considering. So I would get the exact same solution, 0, 0, 2, 3. Now, both of them are valid, but again, I only want unique solutions. So how do I fix this problem? So there's this nice simple fix that we could do. Because the numbers are sorted, all of the numbers would be clumped together, right? So all the zeros would be together. So if at any point we have found a solution for, so let's say first we found the first solution with the first 0, obviously. So any 0 after that, right? So if we go over here or if we go over here, no matter what, we either come up with the same solution or we don't come up with a solution at all. Okay, so that is the essential point over here. So this is exactly what we're going to try to do. And what we're essentially going to do is that each time is, let's say we found a solution with this 0. Now the next number is a 0 again. Since we have found a solution with a 0, right, we found it with one of the zeros, the solution with the next 0 is either going to be the same or it's not going to exist. So there's no point of checking it at all. So we're just going to skip it. Okay, so that is exactly how we're going to solve this problem of not having unique solutions. Cool. And essentially, the same thing that I showed you by just choosing one number, the same thing works with the 2-sum and 3-sum approach as well, right? So let's say I finalize this as x and this is y. I would do the same thing in this case, right? So for this y that I chose over here, I would get the same solution if I'm at this 0. So what I mean by that is, let's say I'm searching for 2 numbers that add up to 5, that's 3 and 2. I would do the same rule, right? So I would look for a solution with this 0, and since I found it, 2 and 3, the next number is also the same number. So in that case, I would either get the same solution or no solution at all. So I could just stop, right? So let's take a look at the code now. Okay, so the first thing we're going to do is, so first we're going to break this problem down, right? So now we're going to, essentially we're solving for 3 sum, right? So let's do that. So we're going to get index 1 comma index 2 in enumerate nums. Cool. Okay, so now essentially what we're doing over here is we are assuming the first value. Think of this as the x. This is the first number we have assumed. So now what we're going to do is we're going to look at a new target. Okay, so target 1, and this is going to be our new target. So this is nothing else but the original target that we have over here minus num1. Again, all that is doing is I'm assuming I have taken this number and I am now going to, instead of doing 4 sum and looking for 4 numbers, I'm only going to look for 3 numbers, but for target 1. Okay, so I'll just write a comment. So 3 sum for target 1. That's essentially all we're going to do right now. Okay, so now we're going to have another for loop. So I'll just do it for index 2 and num2 in enumerate nums. Cool. So in this case, now what I'm going to do is I'm going to get a new target. So this is target 2, and this is going to be target 1 minus num2. Minus num2. Okay, so what exactly does this mean again? So this is the same thing again. I'm breaking it down even more. So essentially now I've made it a 2-sum problem, but for target 2. Okay, so just real quickly, I've assumed the number 1 first, and then I have assumed the number 2. That's it, right? And now I'm just doing 2-sum, which is something we've solved earlier, and it's a lot easier to solve, right? We're just breaking it down. Okay, now let's actually write the code properly, right? So in this case, we get these values. Now, one thing that we have to be very careful for is, in this case, do we have to search all of the values? Well, no, because let's say we get to the last 3 values, right? We're looking for 4 values, so there's no point of going up to the last value. So we could just go up to the last but 3 values. Okay, so up to -3. So there's that. Now another thing that we would do is same thing over here. Is the simple thing you would do is you just do index 1 plus 1 all the way to the ending. But again, same thing over here. We don't have to go all the way to the ending because we're looking for 3 values. So we could just do -2. Perfect. Okay, so now we're going to do the 2-sum part. So let's write the code for that. So I will be using a hash map approach. And another thing you could do is you could use a 2-pointer approach alongside with a sorted array, but I'll just use the hash map approach. Okay, so in this case, we're getting for num3 and nums. Okay, now this is very important. What is the range of values you're going to choose? Well, the basic thing that you might think is the correct answer is index 2 till the ending, but that is actually wrong because what we want to actually do is index 2 in this case, right? So in this case, we're only looking at a subset of the values. Now we're looking at a smaller subset of that. Now in this case, the first index is always going to be 0. So it's not with respect to num's index. Instead, it's with respect to this, okay? The same thing over here, especially over here actually. We're looking at index 1 plus 1, right? So num's 0 is not the same as index 0 plus 1 or anything else, right? So we have to be very careful about that. So in this case, the indexing is actually going to be index 2 plus index 1. And we want to get the next one, right? So plus 1. But now there's another important thing because over here, when you notice, we're doing index 1 plus 1, right? It's not just index 1. So this would actually be index 1 plus 2. Okay, so cool. So now over here, we're going to do the same thing. So, so we're going to initialize a set. So normally we actually used a hash map, but we don't need to do that because we don't need to keep track of the indices. So in this case, we're going to first check if whatever number we're on is part of the set. And now if it is, that means that we have found a solution. But if that's not the case, we're going to add the remaining value to the set. Now this is going to be target 2 minus the current number we're on, which is num3. Okay, perfect. Okay, so now the basic thing that you might think to do is right now you could just directly append the result over here. So let's actually first do that and I will show you what that looks like. So res.append, so let's just append num3, the remaining value. So that is just going to be target 2 minus num3. And then we're going to have num1 and num2. Now this is going to give you the correct solution, but the problem with this over here is that we have not accounted for the for getting repetitions, right? we're not going to get unique solutions. So let's take a look at that. Okay, so cool. Now for this example over here, our solution was accepted, right? We just appended the result and it worked. But now let's say we look at this example over here. So let me show you what happens. Okay, so now in this case, we actually end up repeating 222 several times. Now, technically, when you just look at the indices, all of these 2's probably have different indices and they're still unique values. But this is not a correct solution because they're still not unique, right? We want the values to be unique. So this is where we go back to what we spoke about earlier, which is we want to keep track of the values that were used beforehand, okay? So let us do this one by one, okay? So first, we're going to do that with this over here. So we're going to make sure that in twosome, if we find the same two numbers, we have to make sure that that is not going to be added, okay? So for that, the way we're going to do that is we're going to keep track of all the results of twosome. So let's just do results of sum 2 over here. Now, if at any time we found a result, okay, we're going to add that to this over here. Now, one thing to be careful is we're only going to be tracking these two values, right? Because only those two are produced for twosome, right? The result of twosome especially. So we got this over here. And now one thing we have to make sure is the condition that the same solution is not being repeated. Now, how do we do that? So we first got to have this condition, obviously, to see if we've even found an answer. Now, besides that, we have to first check if whatever value we're on, which is num3, is not the same as the previous value that we were using. So that is just going to be the last value of res of sum, and we're looking at num3, which is at the 0th index. Now, one small thing just to add on is if this is empty, then for the first time, we're going to let it through, right? So let's just check the length of it, and if the length is equal to 0, then we let it through, okay? But if that's not the case, then if the current number, right, as I showed earlier, if the 0 over here is the same as the previous number, right? So if there is a repetition, there is no point of checking it because we would just get the same solution or again, no solution at all. So that is exactly what we are doing over here. So we've added that to the result of sum 2. Perfect. So now we actually have to do this for the other two as well. So let's do the same thing, but for the 3 sum values, okay? So over here, let's do result of sum, but sum 3 in this case. And let's just initialize that as an empty array. Cool. And now we also got to add the solutions with respect to 3 sum over here, right? So the solution would be found at the same place, right? Except we're going to have one extra number. Now that number is going to be num2 over here, right? So we just add that as well. Okay, so now we're going to have to check for 3 sum. So the same way how we checked for repetitions for 2 sum, where exactly do we check for repetitions of 3 sum? Now that would be over here, right? So the way we're going to do that is the same thing. So let me actually just copy this over here. Oh, sorry, this part. So it's the exact same condition. Instead, we're going to check if the length of res of sum 3 is equal to 0 or number 3. So the current number we're on, sorry, that's going to be num2. If num2, right, is the same as the last solution found for res of sum 3, okay? So res of sum 3. Then in that case, we're just going to continue. We're going to skip this number and continue. That's it. Also, sorry about this. If it is not empty, sorry, so we got to just check if it's not empty and if this is true. That's it. Because if it was equal to 0, we don't want to continue. Then in that case, we want it to pause and go and do all of this stuff. Cool. Now we do it for the last step, which is for res itself. So I'm sure you understand the pattern by now, so I'll just copy it. Now in this case, the final result is stored in res. So we're just going to do the same thing. If length of res is not equal to 0 and num1, which is what is for res, is not the same. So if num1 is the same as the previous value, so in this case, if we chose the x as 0, and now we're also choosing x as 0 again, well, there's no point because we have already found a solution with the first x. That's all we're doing. Now in this case, we don't have to continue the entire thing. So we just break out. We continue and move on to the next number. Perfect. Okay. So now the final thing is we've done all of this, but we've never added the values to result. So that would be done right outside of this for loop, right? So in this case, what we would do is we would get all of the values inside of res of sum3. Now the reason we're doing res of sum3 and not res of sum2 is because outside of this for loop, right, the value of num2 could actually change, right? So what was actually proper over here might not be the same value when we're outside of the for loop, right? Obviously. So in this case, we have res of sum3, but when we're in this indentation, the number 1 is still going to be the same. So we can just directly add that. So for x in res of sum3, we first have to add the number 1. So let's extend. So extend num1. And now we're just going to append this to our final result. So res.append x. Alright, so I did make a few small mistakes, so sorry about that. I'll just go through them quickly. So the first was I forgot to sort in the values. Again, like I said, if you do not sort them, then this whole condition of checking the previous value is not going to work. Now, one thing I really messed up when I just copy and pasted this is the fact that over here, what I'm doing is I am checking for the length. If it's 0, or if the last value is not equal to the same thing, then in that case, I am adding that value. But in these two conditions over here, what I'm doing is I'm checking for the opposite, right? Because I want to make sure that if they are the same value, then in that case, I want to skip the entire thing. And if they are not the same value, well, I want to go ahead and look for a solution. So essentially, in this case, I'm checking if they are the same. And if they are the same, well, I continue, which essentially means I just skip it and look for the next value. So the same thing applies over here. Now, another small mistake I made is I just copied this value over here. But for result of sum3, I'm comparing the number 2, not the number 1. So if I look at the index 0, that will give me the number 3, sorry. But instead, I want to get the number 2, which is the last index. Same for res, right? I'm comparing number 1. Number 1 is the last index, right? It's in the last index. So if I submit this, this should get accepted. Yeah, sorry about that, and hopefully this video did help you out, and thanks a lot for watching.